Alright, Justin, what do proteins do?
Proteins help build muscles and tissues. You need this so your body will grow and also that your body can function properly.
Alright, woman, what do proteins consist of?
Proteins are small chains of amino acids and these amino acids are linked together and form a chain from the blueprint. The blueprint has a lot of information that comes from the DNA.
Okay, so you're saying that your DNA has the ingredients on how to make a protein?
That's right, Michael. The DNA is what tells the amino acids what to hook up with each other. It's sort of like Legos. You snap together and form a line, and then it connects with each other to form a ball.
Alright, so what types of food have protein in them, Justin?
Most meat and fish have protein in it. Steak, chicken, bacon, pork, and much more are some of the few meats that have it. Nuts also have a lot of protein, and that makes peanut butter. And this is known for having a good amount of protein in each serving.
How much protein do you want to have daily?
The recommended amount is 20 to 30 grams daily. Depending on what you are doing, you can increase or decrease the amount you intake.
How much is 20 to 30 grams, Justin?
It's about a piece of meat the size of your palm or fist. For me, since I work out a lot, I eat a lot more protein than that. I love my meat, especially bacon.
Yum!
Bacon.
Alright, we're gonna get started on making our bacon tacos. Protein, aka bacon.
Protein. So we're going to make some ground beef right here for our tacos. We're going to put it in the pan, alright? And then put it on the stove and cook it with this stuff.
Now we're gonna use some steaks, because they're good. Bam. Bam. Bam.
Now we're gonna grill some chicken as well. Chicken. More chicken. More chicken. More chicken. And chicken as well.
Okay, we are wrapping the bacons because we are going to use it as the taco shell, and this is what we're going to use. So we're going to put this in the oven and wait for it to cook. Yeah.
Alright, well, this is almost done here. Now we come back to this. What else do we have to add? Add this. Taco seasoning.
And 3/4 cup water.
We got this.
And now
and this.
Now we wait.
Okay, now I'm going to cut up this bacon and make some bacon bits. And we're going to see how this turns out very soon.
Alright, well, we got our bacon bits. Now we're going to put it in here. Start cooking it. Yeah.
The steak is ready, as you can tell. Now it's time to cut it up.
We got our bacon bits ready. And we have our chicken ready. They're both delicious. Just watch the preparation.
So here is the bacon that we're using. Now we're going to try to flip it so it can cook evenly.
Alright, we put the tortilla, wrapped it in bacon. We added some ground beef, steak,
Bacon.
bits. Bacon rain.
Make it
Bacon
rain with
rain on
bacon.
this taco. Right.
Alright, and now it's time for some cheese.
Cheese. More bacon. That's right. You're getting the hang of it. Make it rain some cheese. Alright. Hold the bacon taco.
And add some chicken to the side.
Right there.
And that
Here's your meal.
Who needs these forks and knives?
Proteins and polypeptides are biopolymers that consist of linear chains of amino acids. The amide or peptide link is the characteristic functional group that recurs along the peptide chain. The amino acids differ in the nature of the R groups attached to the alpha carbon atoms, as we will see later. The primary structure of a protein or polypeptide is the linear sequence of amino acids linked by the peptide bonds. A1, A2, and so on represent distinct amino acids, differing in the side group. All organisms use the same 20 amino acids as building blocks. The shape taken up by the chain of amino acids in a protein is called the secondary structure. The secondary structure is governed to a large extent by a hydrogen bonding between segments of the chain. This bonding often leads to a spiral structure known as alpha helix. The hydrogen bonds form between adjacent amino acids along the chain, for example, between acids A3 and A7. Hydrogen atoms bound to the amino nitrogen atoms form hydrogen bonds to carbonyl oxygen atoms. Now let's examine the amino acids, the building blocks of proteins and polypeptides. This shows the amino acid in its neutral or unionized form. However, because the amino group nitrogen is a good base, the proton of the carboxylic acid is transferred to the amino group, forming a zwitterion. Near neutral pH conditions in solution, and in the solid state, amino acids exist as zwitterions. Here are 3 examples of the 20 amino acids that are most commonly found in living organisms. Notice that the central carbon atom in these acids has 4 different groups attached to it. This means that all the amino acids other than glycine, for which the side group is H, are chiral molecules. They are not superimposable on their mirror image, as shown here for alanine. In nature, the amino acids are found in only one of the 2 possible enantiomeric forms labeled L for the direction in which solutions of amino acids rotate the plane of polarized light.